In the previous lessons, we learned how to use this balanced chemical equation to get our mole ratios in terms of the number of mole A equal to the number of mole B. And the way it works is this. Basically, this chemical reaction has 4 different chemicals in it. Because it is balanced, it is equal to each other. And because they are equal to each other, now we can write conversion factor out of them. And all this will be expressed in the unit of mole. 1 mole of methane equal to 2 moles of oxygen, which is equal to 1 mole of carbon dioxide, which is equal to 2 moles of water. And basically, you can choose any 2 of the chemicals in this reaction and make a conversion factor mole A to mole B. Just like we have 1 mole of methane, which is CH4, equal to 2 moles of water. So let's solve this problem. Well, here we have the following conversion factors. So use the given conversion factor below and the chemical equation above to solve the problems below. This is the problem that we're going to solve. And just a reminder again, we can use the chemical equation to get mole A to mole B conversion factor if needed. And hopefully by the end of this lesson, you know exactly if you need it or not. Well, let's look at this problem. How many grams of water are produced from 35 grams of methane? So we know we are working with water and we are working with methane. Well, there are 2 different chemicals that's involved. That means one of the chemical has to be A, and usually A is dealing with the given and B will be our chemical unknown. So that is how you know if you are going to use the mole A to mole B from the chemical equation or not, because the chemicals are completely different. So let's solve this problem. And always we start with our given until we get to all the way to the unknown, which is what we're looking for, and it has to be grams of water. So let's solve this problem. Remember, we always start with our given. So 35.00 gram of CH4 times as many conversion factor as needed to get to our unit and chemical of the known. And the way to do this is multiply 1 conversion factor at a time. And we have a list of conversion factor here, but which one do we multiply first? Well, we're going to look at this part right here. It has grams of methane because we need to cancel this out to get to another unit. Well, which one has the grams of methane? This one right here. So that is right there. So if this is the case, we multiply that conversion factor, which means we have 16.05 grams of methane on the bottom. If this is on the bottom, the 1 mole of methane must be on top. Now do you see that grams of methane cancel each other out? Now what conversion factor do we multiply by next? Well, we look at this one right here. This is our next one. So moles of methane. Which one has mole of methane? Well, we used that one already. We cannot use that anymore. But this one has mole of methane. This one has moles of water. So we have this one. Now we multiply that conversion factor. Well, if this is mole of methane, down here has to be what? 1 mole of methane as well. On top, it is 2 mole of H2O. So we cancel that out. Now, we have moles of water. Well, we are looking for grams of water, so we need to multiply to another conversion factor until we get grams of water. And it turned out that this is our grams of water. In this case, we have moles of water, which is what we're looking for right there. So we can now multiply by that conversion factor, 1 mole of water. If the 1 mole of water is on the bottom, the gram part must be on top, 18.02 grams of water. Notice how moles of water cancel out. Give us grams of water, which is exactly what we're looking for. So how will we plug this into a calculator? Very easy. Multiply everything on top and divide every single number on the bottom. And of course we can ignore 1. So let's do this. We have 35.00 times 1. Let's just multiply everything. Times 2 and times 18.02. 18.02, and then we divide every single number on the bottom divided by 16.05 divided by 1 divided by 1. Of course, we can ignore the 1. And that turned out to be 78.59 grams of what? H2O. Now, let's assume that this is not given to you. How will you solve this out? Well, that is where it's going to get really tricky, because if I don't give you this, it'll be very difficult for you. But you know that you are going to use methane in water, and that's how you get that as well. It's just a little bit tricky because it's not given to you, so be careful with that. Let's try another problem. We have the same concept, use the given conversion factor below. Here we have it, and the chemical reaction and the chemical equation above to solve the problem below. And this is the problem that we're going to solve. And again, we are going to use the chemical equation above to get our mole A to mole B, only if it's needed. And how do we know that we need to use it? Let's look at this question. The reaction above, which is this one here, it is balanced, okay? So it's already balanced for us, so that's nice. Use all of 45 grams of sodium. Well, that is sodium right here. That is not the same thing as this sodium, okay? They are completely different. To produce hydrogen gas, which is H2. And this hydrogen gas, they are not the same as the one in water. So the reaction produced how many grams of hydrogen? So here we have two things. First, we have this chemical sodium, and we have hydrogen. So right there, it tells you that we must, in our problem, use this conversion factor somehow to convert from sodium all the way to hydrogen. But we can look back at this problem, and we know our given is that 1 grams of sodium, and we are looking for grams of hydrogen. And the same thing again, we always start with our given. So we have 45.00 grams of sodium. Now, which conversion factor do we multiply by first? Well, of course it has to have grams of sodium, which is this one right here, because of that grams of sodium. So gram of sodium must be on the bottom to cancel out. Our goal is to cancel out the previous unit so that we convert into a different unit, 22.99 grams of Na. And if this is on the bottom, the other part must be on top, 1 mole of Na. We are done. Notice how grams of sodium cancel out. Now we have moles of Na. We don't have grams of H2 yet, so we have to multiply by another conversion factor. In this case, what do we have? Moles of Na. Which one has mole of Na? This one has moles of Na. So we're going to multiply by that one. And how many? And if this is not given to us, we can solve it by 2 moles of Na equal to 1 mole of hydrogen. That's pretty easy. So now we have 2 mole of Na, which is sodium, and the top part must be 1 mole of hydrogen. Notice how moles of sodium cancel out, or Na cancel out. Timed by the next conversion factor, that's because we don't have our grams of hydrogen yet. But here you go, we have our grams of hydrogen. And perfectly fit, now we have moles of hydrogen as well, which is that one. So now we have 1 mole of hydrogen. And therefore, the top part must be 2.02 gram of hydrogen. That cancel out. And all we have to do now is just plug in our calculator. Multiply everything on top, divide by everything on the bottom. So let's do this. We have 45.00. Multiply by 1, multiply by 1. We can ignore that. Multiply by 2.02. And then divide everything on the bottom, divided by 22.99. And divided by 2 again. We ignore the 1. So our answer is 1.97. That would be 1.98. So we have 1.98 grams of hydrogen. And that is how we do it in terms of solving using multiple conversion factor. And again, if this is not given to you, just use that. 2 moles of Na equal to 1 mole of hydrogen. Either way is fine.